So there's a few things we're going to take care of in section 5.8, among which is dividing a polynomial by a binomial. Now, to kind of set the stage for that, we're going to do an old-fashioned division problem, some long division, 23 into 5,438. Well, let's just review this. Now, I'm not going to make you do problems like this, but it's just going to kind of set the stage for what we're going to do in long division of polynomials. So the first thing we do is we compare these two things, right? We want to figure out, what do I multiply this by to get this? Well, 23 doesn't go into 5, does it? So let's move over. Does 23 go into 54? How many times? Any more? Twice? So let me put a 2 up here. What do I do with that 2 then? Two times 23 is 46. Put it on 54. All right, good. So figure out, then multiply. Now what? Subtract. So we're going to subtract these two here. That'll give me an 8. Bring down the 3. Then this process repeats itself. How many times does 23 go into 83? 3. 3 times this, our multiplication step is 69. Then we have another subtraction step. Subtract, we get 14. Then what? Bring down the 8. Thank you, sir. So bring down the 8. How many times does 23 go into 148? Well done, 6 times. 6 times this gives me 100 and what? That'd be 38. Now what I like about doing it this way and keeping all these things lined up is that it kind of tells you when to stop. Now we're getting down to the decimal. So what's left? I mean, you could go into decimals, or you could just say that this is the remainder. So 5,438 divided by 23 is 236. Remainder 10, or you could also write it as 10 over 23. So that's kind of a basic flow of these types of problems. It's not going to be really much different for our division of polynomials. So let's take a quick look at the handout. First thing I want to call your attention to is the fact that you can write these problems in any of 3 ways, any of 3 equivalent ways. So you can have a fraction, something divided by something else, so that's one way. You can have something written out with division sign, or you could use this last one, which is going to be of interest and of use to us, another division sign. Divide the denominator into that numerator. We're going to use the same basic steps that we used just a minute ago. Now I've heard people summarize those steps with kind of this acronym: father, mother, sister, brother. And then there's the optional R for Rufus, which is your dog. Okay, so what do all these things mean? The first thing we have to do when we're dividing this into this is to figure out, well, what am I going to multiply by? If you look back, I think James picked out real quickly that when we began this problem, we wanted to multiply 23 by 2 in order to get close to 54. We're going to do the same thing here. What do you multiply 2a by to get 8a squared? Well, the answer is 4a. Now, if you can't see that, if you're like, oh, how did you get that I need to write a 4a up here? That's a good question. What you're going to do is you're going to compare these leading terms. You can take this leading term and divide it by that leading term. 8a squared divided by 2a. 8 divided by 2 is 4. Subtract the exponents, I get a 4a. All right, so that's kind of your first step, your figure step. So here's the f. The next is the multiply. Father, mother. So here's your multiplication step. You're going to take that 4a and multiply it by this whole term out in front, by 2a minus 1. When I do that, I have to distribute. 8a squared minus 4a. So that's the multiplication step. And I took that expression here and I wrote it over here. We've got to subtract that thing now. At the end of the last section, 5.8 or 5.7, I made a big deal about subtracting polynomials. That's because if you mess up with a sign here, then it's generally going to just really torpedo your problem. Usually gets worse. So the big trick back then was to change the signs, then add. So instead of a minus, subtraction sign, that's going to be a plus. Instead of a positive 8a squared, it becomes a negative 8a squared. Instead of a minus 4a, it becomes a plus 4a. And now we'll just do some addition. 8 and negative 8 cancel, gives me 0. 2 and 4 gives me 6, 6a. Father, mother, sister. The brother step is just to bring this next term down. Bring down the negative 3. And then we're going to repeat this process. Now these problems are challenging. There's a lot of little parts to it, but those parts are a good review of a lot of other things we've done. We're going to do some monomial division like this a little bit later. You've got multiplication of monomials times binomials. You've got subtraction of polynomials. It brings together a lot of stuff. So I know they're challenging, but try and stay with me because they're big point problems on your next exam, and I want you to get them right. Father, mother, sister, brother, and then repeat. So we're back to this step. I need to figure out what do you multiply 2a by to get 6a? What times 2a gives you 6a? 3. So it'll be a plus 3. If you take that plus 3 and multiply it by that term out in front, what do I get when I distribute that? Derek? The 3? Thank you. 6a minus 3. So that's 6a minus 3 here gets subtracted from this term here. 6a minus 3. Then what? Change the signs and add. How's that going to look? Well, that becomes a plus, that becomes a minus, that becomes a plus. Nick, when I add these together, what do I get? These last two sets. 0, yeah. So that's good. That means 0 is our remainder. And regardless of whether or not we get a remainder other than 0 or not, we're done here. That's your quotient. That is your answer. 2a minus 1 goes into this that many times. 4a plus 3. Yes, sir?
When we get to the change of sign with the how come we add a negative the first time, but the second step we just add? Why don't we add a negative?
I'm not sure where you want that extra negative.
Plus negative 6a.
Okay.
Why doesn't it?
Well, you have minus, you could write minus negative 3, which is effectively a plus 3. So let me look back at that again. So here's where we were. In order to account for this, I'm going to change the signs, then add. So that becomes a plus. The sign on this was positive, so that becomes negative. The sign on this is negative, so it becomes positive. But if you wanted to think of it, you could think of it as subtracting negative 3. But subtracting negative 3 is the same thing as adding 3. So I think it's easier just to change the sign on both of these terms is what you're going to do. We're doing likewise up here. This becomes a minus, this becomes a plus. So those two cancel each other out. 2 and the 4 give me a 6. So just change the signs is probably the most efficient way to do it, I would suggest. Does that help you out, or you still want to follow up? Okay. That was very diplomatic, thank you. All right. Let's try it again. Now, what I want you to do is start trying to really catch on to this. I mean, it's not enough just to sit back and watch it. You really got to be engaged on these problems. Like I said, they're heavy hitters on an exam. They bring together a lot of the stuff that you've done in Chapter 5. So you're given more responsibility, more things to do on this one than you were in the last one. So let's try and keep up. Try and get into the flow. I know they're tough. Back to our same bunch of steps here. Father, mother, sister, brother, and then repeat. So the first thing to do is to figure out what you're going to multiply by. I helped you out on that one. You're going to compare the 3x and the 6x cubed. What do you multiply 3x by to get 6x cubed? If you can't do that in your head, that's fine. Just set up this little division here. This divided by this. 6x cubed divided by 3x gives me 2x squared. So I'll put that here. So that's your first step, father step. The next step is the multiplication. Take that 2x and multiply it by that binomial out in front. There's a little disconnect here. Because in the father step, this figuring out step, we only looked at the first two. But once we got the 2x squared, you have to multiply that 2x squared by both of these. That's just the nature of this. So 2x squared times 3x minus 2. When I distribute that, I get 6x cubed minus 4x squared. So I get that, which I'll put right here. 6x cubed minus 4x squared. The big step here is to change the signs, then add. This negative has to distribute itself to both of these terms. So this becomes a plus, that's a minus, and that's a plus. Negative 6 and positive 6 give me a 0, so those cancel each other out. Negative 1 and positive 4 give me a 3, plus 4x. Nice. So then what? Well, this stuff repeats itself. We brought down the 4x. Now it's back to figure out what you need. What are we going to end up with next? So I need some participation here, especially if you don't usually help out. Here's your chance. I need to figure out what do I multiply 3x by to get 3x squared? X. To help you see that, what you could do is take 3x squared, this, divided by this. The 3's cancel, x squared divided by x gives you just the x. So let's put that x right up here. So it's going to be a plus x. Keep up with things because you're going to be doing the next one. So that's your father step. The mother step, the multiplication, is to multiply that x by that term out in front. I get 3x squared minus 2x. Let's see. Let's do it this way. Blue here and blue here. 3x squared minus 2x. So I took that term here and I put it here. Let's distribute this. Change the signs and add. Plus here. So that makes this a minus and this a plus. When I add those terms together, what do I get? Yeah. So these two cancel each other out. 2 and 4 gives me 6. So 6x minus 4. All right. It's up to you to do the last one. Is there any questions before I give you the last one to finish up on your own? I'm going to walk around and see how you're doing. All right. Give that one a shot. See if you can't figure out that last little bit. I'm trusting that you two are on the same page, so it helps me out. That's my shortcut. Okay. All right, so last but not least here, we need to figure out what do you multiply this by to get this. So that is 6x divided by 3x gives me 2. And that 2 is going to have to go up top. So right there. So a plus 2. If I take that 2 and I multiply it by that term that I have out in front, so kind of keeping things color coordinated again, that 3x minus 2 gives me 6x minus 4. That 6x minus 4 is what comes down here. And the last step is to change the signs, then add. Let's make that a plus and change both of the signs inside. When I add these together, 4 and negative 4 gives me 0. 6 and negative 6 gives me 0. So there's my answer right here. 2x squared plus x plus 2. Whew. All right, we're going to do a couple more like this. But before I leave this one, is there any details here that you'd like a little bit more help with? I think I got around to all of you, so I'm hoping you're doing all right. But if there's something else, there's a good time to get some help. Okay. Let's try problem number 66. Three b squared minus 5b plus 2 divided by 3b minus 2. I guess where I'd start this one out is by realizing that we can rewrite this in an equivalent way. This is 3b minus 2 into 3b squared minus 5b plus 2. Same kind of steps here. I need some help from you guys though. What am I going to multiply by to start with? B. If you can't see that, if you're like, I don't know, what you can do is you can compare the leading coefficients. 3b squared divided by 3b gives you b. So that's where that b goes. That's where it comes from, that's where it goes. Now, let's take that b and multiply it by this term out in front. B times 3b minus 2 gives you 3b squared minus 2b. 3b squared minus 2b. Let's put parentheses around the whole thing and subtract it. What's the big step that I have to do here? Change the signs. Good. So this becomes a plus, that's a minus, and that's a plus. You're basically distributing that negative sign to both of those terms. When you add, these terms, these first two terms cancel each other out. If you're doing your work right, they should always cancel each other out. The next two terms, maybe they'll cancel, maybe they won't. In this case, they don't. Negative 3b plus 2. All right, halfway there. I need to repeat this process. Now I want to look at this leading coefficient and this leading coefficient. What do I multiply 3b by to get negative 3b? Negative 1. If you can't see that, that's all right. Set up a little division for yourself. Divide this by this. The b's cancel. Negative 3 divided by 3 is negative 1. So let's take that, put it in its rightful spot. So that's going to go right over here. So minus 1. Then I want to take that minus 1 and multiply it by that term out in front. So let's kind of keep things color coordinated here. 3b minus 2 times negative 1 gives you negative 3b plus 2. Keep in mind that you're going to subtract that term, though. When you subtract, change the signs, then add, what are we left with? 0. So 0 remainder again. Now, if you got something other than 0, what you could do for your answer would just be to put that over the divisor. So our answer in this problem is b minus 1 plus 0 over 3b minus 2. Now, in the case of a 0 remainder, you don't have to do this. That's fine. Just give me the b minus 1. But if that's something other than 0, then yeah, put it over the divisor. Now, these problems are challenging. I understand that. So it's important that you get some help here. How are we looking on these? Are we getting a little bit better on them? We're taking our time on these. I want to give you a lot of help on them. Are there any questions on this that you have for me at this point? Yes?
When it was 5 3b2 plus 3b plus 2, I thought that was minus 3b plus 2, like both the same.
Well, I mean, initially they were both the same, but then you had to subtract them. And when you subtract them, it changed the signs on those terms.
Okay.
So, good question. Other things on problem 66 here. Now, for a 10-point problem on an exam, maybe you're thinking to yourself, boy, I don't want to get this one wrong. It'd be nice to be able to check it. You can check it. You can check it by multiplying. So let's take 3b minus 2 times b minus 1 and multiply those together. What do you think I should get when I FOIL these together? Perfect. 3b squared minus 5b plus 2. Let's see that happens. First terms would be a 3b squared. Outside terms would be a minus 3b. Inside terms would be a minus 2b. Minus 2b. Minus 2 and a minus 1 gives me a plus 2. When I add these together, I get 3b squared minus 5b plus 2. It checks. So, nice. Let's try problem number 70. I see. I got 72 on the list, but I think I might want to do a different one. Give you a nice example of something else that can happen, because we've done a couple that are pretty straightforward. You know what? There is something that I do want to draw your attention to in problem number 72. We're not actually going to take the time to do 72, although here it is. Initially, the problem is written like this: x minus 2 plus 6x squared. It's important for your sanity and making this problem easier that you rearrange these terms so that they're in descending order. So they have an x squared, an x, and then a constant, or an x cubed, an x squared, an x, and then a constant depending on the problem. And that's actually key to problem. Where is it? Problem 73 is the one that's in your homework, but I'm guessing problem 74 is the one that I want to do next. Yeah, problem 74. So let's take a look at that one. X cubed minus 8 divided by x minus 2. If you look at this, boy, it's really tempting. It's really tempting to just say, hey, I cancel out the x's and cancel out the 8. 2 into 8 4 times. So you get x squared minus 4. It'd be nice if they were true, but it doesn't quite work that way. In the numerator, there's a couple terms that are missing here. What kind of terms might you expect to see in something with a third power? What other terms? A squared term and an x term. So even though they're not explicitly written, you could think of it like this: x squared plus 0x, x cubed plus 0x squared plus 0x minus 8. Now, what's 0 times anything? 0. So I'm not really adding in things. The only reason I put them there is for placeholders, just to keep organized as I do my division problem. So x minus 2 into x cubed plus 0x squared plus 0x minus 8. Now I'll do a little bit of this, and I'll let you finish it up. First thing I want to do is figure out, what do I multiply x by to get an x cubed? X squared. I'm going to write that right over here. You can take x cubed divided by x, get an x squared. That's where that first term comes from. Let's take that x squared and multiply it by the binomial out in front, x minus 2. So here's your binomial out in front. So I get x cubed minus 2x squared. That has to be subtracted here. So Robert, let's change the signs and add. So that becomes a plus. What do I get in here? Good. Minus x cubed. Yes, that's all right. Now the nice thing about the way we've written this is that we can add these things straight down. X cubed and minus x cubed, those cancel. 0x squared and 2x squared gives me 2x squared. I actually have something here. For people who try and do it without these extra placeholders and spacers, boy, they get really confused. I strongly suggest you put them there. Do you want to handle it from here, or do you want me to do one more step? Okay, it's all you then. All right. So next step is we got to figure out what to multiply this by and this. So we can do a little division. I'm sorry I didn't get to you guys over here. Let's see how we're doing on this one. Again, you want to compare the leading coefficients. So that's going to be, in this step, it's going to be this one and this one. If you can just look at that and say, gee, I need to multiply by a 2x, that's fine. If you can't, here it is. 2x squared divided by x gives me an x. So let's see, that x here is going to go here. So x squared plus, you know what? I said x, that meant 2x. X squared, yeah. A few people are going, wait a minute. Oh, whew. Yeah. All right, so a 2x. Let's take that 2x now. So I use that 2x, goes up here, and it also helps me out here. I'm going to take that 2x times this term out in front, the x minus 2. If I distribute that, I get 2x squared minus 4x. 2x squared minus 4x. And that's what I have to subtract here. So just write it down, put big parentheses around it on the outside, and we'll change the signs, then add. Plus, minus, plus. These cancel each other out. They always should cancel each other out. If they don't, if you have a 2x squared and a 2x squared, there's something wrong. 0 and 4 gives me 4, so 4x. Bring down the minus 8. Now we're almost done. One last step. I need to compare the x and the 4x. What do I multiply this by to get this? 4. And again, you can do a little comparison if you want. You can take this divided by that. 4x divided by x is 4. Take that 4 times x minus 2. It gives me 4x minus 8. Again, big parentheses and a subtraction. Let's put that 4 up where it belongs. So that one goes all the way up here. So plus 4. Change the signs and add, and then everything goes away, right? Lion and the lamb are best friends. Republicans and Democrats always agree. And you get a 0 there. Cool. All right. A long one for sure. These need a lot of practice. Do not blow these off over the weekend. I'll catch up next week, etc. You don't want to do that. You want to work on these now while it's fresh. In fact, do some tonight. Do a couple problems tonight. It helps reinforce your memory because your short-term memory is just that. It's short-term. Until you start working with this stuff, move it into your long-term memory, burn it into your memory traces, then you're going to forget it. So get back to this as soon as possible. There's your answer. X squared plus 2x plus 4. Okay, there's a couple more problems that we're going to do to finish off this section. About 3 of them. But this is the hard stuff. This is the stuff that I wanted to spend the most time on, and of course we did. The remaining stuff is a little bit of what we're doing right here, this monomial division. In fact, this whole problem is just a big rehash of some of the stuff that we've done in this chapter. You're doing a multiplication of a binomial times a monomial. You're doing a monomial division. What else are you doing? You're doing polynomial subtraction. So there's a lot of stuff that's in here, in these problems. It's not that I actually really like these problems, but they're good problems for you to be tested on to show me that you've been keeping up with all the stuff that we've covered in Chapter 5. All right, onward then. Last little bit here for this section. And that is to start by recalling something that we've done a long time ago. And that is when we had two things the same denominator. What could I do with the numerators? Not all at once. What could I do with the numerators? How could I rewrite this? a plus c over b. Good, just add the numerators. Thank you. Well, the thing is, you can use this in both directions. If you started out with something like this, you could split it up into this a over b plus c over b. You could work it in the opposite direction. Case in point would be a problem like number 26. 8x plus 4 over 4. It's really tempting for a lot of people to want to cancel that 4 and say, oh, good, 8x plus 1. You can't. You can't cancel the 4 into the 8x. But what you can do, instead of canceling just one of these, is you can divide both of them by 4. Now the difference is here, in the original problem, those terms are stuck together. I can't cancel into that because it's an addition. But here, there's no addition between these, so I can do some cancellation. 4 goes into 8 twice. So 2x plus what? Thank you. 2x plus 1. Yay. And that's it for problem number 26. Let's try some more here. Problem number 32. A little bit more challenging. (16b to the 10th plus 4b to the 6th minus 20b to the 4th, all divided by 4b squared. Now what I would want to see in a problem like this, and you'd probably get a point of partial credit just by doing this little much, is divide each of these terms in the numerator by that term in the denominator. So 16b to the 10th divided by 4b squared plus 4b to the 6th divided by 4b squared minus 20b to the 4th divided by 4b squared. Okay, looking good. Let's simplify each one of these now. What's 16 divided by 4? 4. How about with the exponents? How many b's do I have? 8. Good, because you're subtracting here. 10 minus 2 gives me b to the 8th. Dwayne, how about the next term? What would I get here? Perfect, b to the 4th. The 4's cancel, subtract exponents, b to the 4th. Thank you. Autumn, how about the next one, the last one? Minus what? 5b squared. Beautiful. Thank you both. Let's do one last one like this. This could be problem number 36. Negative 30, a to the 4th, b to the 4th, minus 15, a cubed, b cubed, or excuse me, a cubed, b, minus 10, a squared, b squared, all over negative 10, a to the 2nd, b to the 3rd. Just like the last one, we're going to start this one by dividing every term in the numerator by that term in the denominator. That includes the negative that's part of the negative 10 here. So negative 30, a to the 4th, b to the 4th, divided by negative 10, a squared, b cubed. Now my personal habit is just to separate these things by whatever sign is in the numerator. So minus 15a cubed b over negative 10 a squared b cubed. Minus, that minus reflects this minus here. 10 a squared b squared divided by negative 10 a squared b cubed. There's a lot of simplification that can and should take place here. Why don't you give yourself a few seconds to see if you can't do some of it. Cancel out coefficients. Change the signs. Subtract exponents. Write your final answer with positive exponents. Okay. How do I look at this? Kendra, maybe you can start us out with the first one. What kind of simplification do I get here? Good. B to the first power. Do I need to write the 1 there? No. So we'll just leave it as 3a squared b. Thank you. Danielle. Let's see, a negative and negative here make a positive. Is there a common factor between 10 and 15? 5. So 5 goes in here twice and in here 3 times. So I'll end up with a 3 here and a 2 here. Good. How about the exponents? What can we do with the exponents? All right, subtract the exponents. Thank you. So 3 minus 2 gives me an a to the first power over here. I'm just going to write it as a. And where do I have more exponents for the b's? In the numerator or denominator? Denominator. So let's do it this way. 3 minus 1 will give me a b squared here. And we'll leave it in the denominator because that's where I had more of them. And if you just subtracted, you get 1 minus 3 is negative 2, but you'd end up putting it in the denominator anyways to get rid of the negative. Good, thank you. And let's see. LeBaron. Maybe we can do the last one together here. Negative, negative makes a positive. Is there any other simplification that I get there? All right, the a squareds cancel each other out. That's good. There's another nice big cancellation that we can do. Yeah, let's take out the 10s. Good. And now, did you catch what happened in the last one? I did 3 minus 1 because I had more of them in the denominator than I had the numerator. So I left with a b squared here. What would I be left with for this last one? Three minus 2 would be b to the first power, right? Wouldn't be just b. Well, it's b in the denominator, but what's in the numerator? What should I put in the numerator? A 1. A 1. 1's what's left in the numerator. For homework, try 13 through 35, 45 through 73, and 85 through 91. Let me give you a hint on number 73. This is section 5.8. X cubed plus 1 over x plus 1. when it comes to the division part of this, the long division, I think you should probably take account of the terms that are missing. I mean, the only thing that you see written there is the x cubed plus 1. What missing terms am I talking about? How can I kind of augment this problem a little bit? Plus 0x squared plus 0x. Make sure you put a 0 in there. If you just left it as x squared, then really the understood coefficient there would be a 1. You need to put a 0 in there. Good luck with that.